Homework 12 is working with inequalities, those greater thans and less thans and greater than or equal to and less than or equal to. When we solve an inequality, we solve it just like we solve an equation, except if we end up multiplying or dividing by a negative number. So these first ones, we're just going to do adding and subtracting. So our inequality sign is going to stay the same because we're not doing any multiplying or dividing, so we don't have to worry about that rule. So we just solve it exactly like we solve our normal equation. If I want to solve this for z, I need to move the 2 to the other side. I'm going to minus the 2, so 18 is less than z. When you enter it in, you either need to just leave it in that order, which is what I would suggest, or if you turned it around so it makes sense to you, if 18 is less than z, you have to flip the whole thing around, then z is greater than 18. I personally would just leave it alone so that I don't mess up on anything when I changed it, but if you want this variable to be first, you flip the whole thing. So on number 2, if I'm solving for t, what would I do? Add the 5. 17 plus 5 would give me 22 is greater than t. And you have to enter that whole inequality in there. It's not just 22. It's 22 is greater than t. And I moved mine around because I wanted to make the font a little bigger so my pages aren't going to line up with yours, but it'll be the same questions. Number 3, solving that for z, we would add 3, and so z is greater than or equal to 28, right? Now once we get to 4, 5, and 6, now we have to remember that rule for multiplying and dividing. If you multiply or divide by a negative number, which means your coefficient is negative, then you have to flip your inequality sign. So on this first one, in order to solve it, I have to divide by negative 5. Since I'm dividing by a negative 5, my inequality sign is going to flip and be greater than or equal to. Then I simplify the other side as much as possible. In this case, I've got a negative over a negative, so it becomes positive, but I really can't do anything with the 14/5. So x is greater than or equal to 14/5. Number 5 here, there's actually 2 different ways you could solve this one. The first way is, if I get rid of that fraction, what would I do?
Times it by negative 4.
If I times it by negative 4 and I include the negative, I'm multiplying by a negative 4, which means I have to flip my sign. W is less than negative 44. That's the quickest way to solve it. Some people do it this way, just for an example, because it's perfectly legitimate to do. Is they say, oh, I got to multiply by the 4, and they just multiply by 4. Well, if I multiply by the 4, I'm not changing my sign. I would say negative w is greater than 44. However, then they have to get rid of that negative, so they end up having to divide by negative 1. Now I'm dividing by that negative. I have to flip my sign. And you can say either way I end up with the same answer. Both of them are perfectly legitimate things to do. This obviously was the shorter way to do it if you remember to put the negative with your bottom number and just multiply by with it right away. So, one of the few cases you actually multiply by a negative to solve. Number 6, if we're going to solve that for z, we're going to divide by negative 4, right? You guys are so talkative. Again, I divided by a negative, so I have to flip my inequality sign. 20 divided by negative 4, that one comes out to a nice integer. Z is greater than negative 5. Then you get to the 2-step inequalities. Again, where you have to decide on that last step. If I multiply or divide, usually it's dividing by a negative, I flip my inequality. If it's positive, I leave it alone. So my first step is just the adding and subtracting. I want to move my 5 over. I'm going to subtract 5. 5x is greater than or equal to negative 30. On the adding and subtracting, that sign shouldn't change, ever. Here I'm going to divide. I'm going to divide by a positive 5, so my sign's going to stay the same way. X is going to be greater than or equal to, and then I simplify my fraction, negative 6. So if this coefficient is positive, my sign's going to stay the same way. So number 8, if I'm going to solve that for W, the first thing I'm going to do is add the 8. 6W is less than 16 plus 8, 24. Then I'm going to divide by 6. Since that's positive, I leave my inequality sign alone, so W is less than 4. Number 9, 11 is less than or equal to 1 plus 2W. The first thing there I should minus the 1. 10 is less than or equal to 2V. I'm then going to divide by 2. Again, that's positive, so I leave it alone. 5 is less than or equal to V. So problem type 1, all of your coefficients were positive. Type 2, they're now going to change to negative, but when you're doing the assessment, it's not going to tell you if it's type 1 or type 2. So in number 10, if I'm going to solve that for you, I'm first going to subtract my 7. Negative 20 is less than negative 5u. Now I'm going to divide by a negative 5. Since I'm dividing by a negative, I have to switch my inequality. Negative 20 divided by negative 5 is 4. I'm going to flip my sign, is greater than u, and again, I would just leave it in that order. If you want to do u is less than 4, it's the same thing. So number 11, if I'm going to solve that for y, the first thing I'm going to do is minus my 22. Negative 7y is going to be greater than 8 minus 22 is negative 14. I'm then going to divide by my negative 7, right? If I divide by negative 7, what should my answer be?
2. Negative 2. Or no, you.
It's not just 2. It is
Y is less than.
y is less than 2 because I had to flip my sign since I divided by a negative. So number 12, if I'm going to solve that for v, the first thing I'm going to do is add the 18. Negative 6 plus 18 is 12. So 12 is greater than or equal to negative 2v. Then I'm going to divide by negative 2, and my answer is going to be
Negative 6 is less than or equal to v.
negative 6 is less than or equal to v. Again, I divided by a negative, so I had to reverse my inequality sign. Type 3. Now they threw those fractions in there along with my inequality sign, so now I got to remember my rule when I have fractions. If I have a fraction in my problem, the first thing I like to do is get rid of the fractions by multiplying by the common denominator, just like we did when we had those equations. Yes, you can do it with the fractions and adding and subtracting those fractions and all of that good stuff, but it's a lot more work. In this case, I'm going to look, my common denominator is 6. I have to multiply every term by 6. So times 6 here, times 6 here, times 6 here, times 6 there. There's 4 terms there. On my fractions, I'm going to be able to cancel. 3 goes into 6 2 times. 2 times negative 4 would be negative 8u. Here I don't have a fraction. I can't cancel. I'm going to take 6 times negative 1, which is negative 6. Then I have is greater than or equal to. 3 goes into 6 2 times. 2 times 5 is 10, so I get 10u. 6 goes into 6 once. 1 times 7 is still 7. My common denominator should be a positive number, so I shouldn't be changing any signs on that step there. Now I got to do my adding and subtracting again. When we add and subtract, the inequality sign shouldn't change. We're just going to move our variables to one side, our numbers to the other side. Now, some people don't like to have that negative coefficient, so they move their variable whatever way makes their coefficient positive. So instead of moving this u to the left like we usually do when we solve equations, they might decide, let's move the u to the right, because then I have a positive 18 and I don't have to remember to flip my sign at the end. So if I move this over here to the right, that means I want to move this over here to the left. We would get negative 13 is greater than or equal to 18u. We then have to divide by the 18 to solve. So negative 13/18 is greater than or equal to u. So if I look at number 14, what should I multiply by? $28, because I have a 4 and a 7 in my denominators, right? I'm going to multiply every term by 28, including those whole numbers. But I want to have something both 4 and 7 will cancel out with, so I can get rid of those two fractions. 4 goes into 28 7 times. 7 times 3u, 21u. The 1 I can't cancel, I'm just going to take the 28 times the 1, which is still 28, is greater than or equal to. Here I'm going to take 28 times negative u, negative 28u. And then I got a fraction, so I'm going to cancel again. 7 goes into 28 4 times. 4 times my minus 5 is minus 20. And then I want to go ahead and solve that for u. If I'm going to solve that for u, what might you do?
Add 28.
Add the 28u. That way my u stays positive. And then I'm going to subtract that 28 to move the number to the opposite side of my variable. If I do that, 21u plus 28u would be 49u. Is greater than or equal to negative 20 minus 28 is a negative 48. And in order to solve that, I'm going to divide by the 49, right? So u is greater than or equal to negative 48/49. So number 15, if I want to get rid of my fractions there, the first thing I want to do is
Multiply by 18.
multiply by 18. 9 and 6 both divide into 18. If you use 54, it should work. You're just going to have a number at the end that you have to reduce more. So if you use your least common multiple, your numbers aren't as big. So 9 goes into 18. 2 times negative 5v, negative 10v. Here I don't have a fraction, I can't cancel, so I have to take 18 times negative 2. Negative 36 is less than or equal to. Here I have a fraction, 6 goes into 18. 3 times my 7v, 21b. And then again, we have a fraction on the end. 9 goes into 18.
Twice.
Twice. 2 times 4
8.
is 8. So negative 10b minus 36 is less than or equal to 21b plus 8. What's the next thing you might want to do to solve that for b?
Add the 10 to B.
Add the 10. See, she doesn't want to have that negative, so she's going to move that over and add the 10b, which means she's also going to
Minus the 8.
minus the 8 to move it to the other side. So negative 36 minus 8 would be negative 44 is less than or equal to 21 plus 10 is 31b. And then all we have to do is divide by 31. I don't think I can simplify that fraction, so I have negative 44 over 31 is less than or equal to b, keeping it in the right order. Solving a compound linear inequality, graph the solution. Basic, it says. If we have a compound inequality, means you have two separate inequalities. Sometimes they have them smushed together as one. This means that the negative 12 is less than or equal to 4x plus 4, but the 4x plus 4 also has to be less than the 16. So if you wanted to, you could split it into two separate problems. However, I'm going to rewrite it down here. You end up doing the same steps. If I'm going to solve this problem here, the first thing I'm going to do is minus the 4, and same thing over here. So if I'm solving a compound inequality where I have something in the middle, instead of having to do two separate problems, I'm just going to do both sides of it. Here I want to get the x by itself, so when I move the x, I'm going to minus the 4 here and minus the 4 over here. Negative 16 is less than or equal to 4x, which is less than 12 then. Be the same thing as I got over here if I did them both separately. Same thing on my next step. My next step on both of these two equations here would be dividing by the 4. So when I divide by the 4 here, I have to divide by the 4 on both sides. Negative 4 is less than or equal to v, or x. It should have been an x. Just can't write. Which is less than 3. Same thing I would have got over here. So if I would have separated them into two problems, I would have ended up in the end putting it all back together, which is the same thing I got over here when I just worked the whole thing at once. So again, if you want to, I'm not even sure what Alex does. If they write it down two ways, they probably have an alternate solution. I prefer this way because it's less work than having to do that. So I minus the 4 from both sides. I divided by the 4 on both sides, and I have it solved. I still have to graph my solution. If I have the less than or equal to, I have the filled in circle. If I just have the less than, I have the open circle. The x is between my two numbers, so I'm shading between my two end marks. Number 17 is one that has an or. To me, when I read that or, it tells me that when I get done with my answer, I'm either going this way or this way. It's not going to be in the middle. It's the two opposite ends. But we should get that when we solve it anyway. So on this one, we have two separate equations. We just have to solve them both separately. 4x plus 1 is less than or equal to negative 15. 3x minus 5 is greater than 1. I'm just going to solve my first one. So starting out, I've got to minus my 1. 4x is less than or equal to negative 16. and then of course divide by my 4. X is less than or equal to -4. Then I'm going to solve my other one. Got to move my 5, so I'm going to add the 5. 3x is greater than 6. Divide by my 3. X is greater than 2. I do my end marks first before I do any shading. This one has the equal to bar, so on the -4, I have that filled in dot. This one doesn't have the equal to, so on the 2 I have my open circle. But I'm less than the -4 means I'm going to the left. Greater than the 2 means I'm going to the right. And you can see that you ended up, since it was an or, going in the 2 opposite directions. Ors always go the opposite direction, and is in the middle. Number 18, back to one of those compound ones that says 7 is less than 2x plus 5, which is less than or equal to 17. So if I just solve that all together, the first thing I want to do is, you want Amy? First thing I should do here is minus the 5. So I'm going to get rid of the 5 from the middle, and I'm going to minus the 5 from both sides of my equation. So 2 is less than 2x, which is less than or equal to 12 then. Now I'm going to divide by 2. Again, I'm dividing by 2 on both ends. So 1 is less than x, which is less than or equal to 6. So on the 1, what kind of end mark do I have? What kind of end mark do I put on the 1? The open circle, because I'm not equal to the 1, so I put an open circle on that one. On the 6, filled in circle. And where am I going to shade? In between those 2 dots, because x is in the middle of the 1 and the 6. (19, 20, and 21 are solving a word problem using a linear inequality. So we're going to use greater than, less than, greater than or equal to, less than or equal to, whatever it tells us here. It says to rent a certain meeting room, a college charges a reservation fee of $49 and an additional fee of $6.40 per hour. The math club wants to spend less than $106.60 on renting the meeting room. What are the possible amounts of time for which they could rent the meeting room? Use T for the number of hours. So, paid $49 to rent to reserve the room. I'm going to pay an additional fee of $6.40 per hour. So I'm going to have $6.40 T, since it told me I had to use T for the number of hours. I want to spend less than $106.60. So I've got my inequality written down. I want to solve that for T. The first thing I should do is minus the 49. I'm going to let you go ahead and do that for me with your calculator so I don't mess up on my subtraction. So 106.60 minus 49.
57.60.
57.60. And then in order to solve that for T, I'm going to
Divide by the 640.
divide by the 640. T is going to be less than Now, that means if they rent the hall for less than 9 hours, they're going to stay within their budget. If they go over 9 hours, then they're going to spend too much. Lamar is going to rent a truck for 1 day. There are 2 companies he can choose from, and they have the following prices. Company A charges $93 and allows unlimited mileage. Company B has an initial fee of $65 and charges an additional 80 cents for every mile driven. For what mileages will Company A charge less than Company B? Use M for the number of miles driven. So for Company A, they're going to charge me $93. Doesn't matter if I drive 1 mile or 900 miles, I'm going to pay $93. Company B is going to charge me $65 to start with, but I'm going to have to pay an additional 80 cents for every mile driven, and it told me to use M for my miles. We want A to charge less than B, so we want the 93 to be less than the 65 plus 80 cents M. I didn't leave myself much, or you guys much room for writing. Maybe you're writing smaller than me. To solve this, of course, we're going to subtract our 65. 93 minus 65 is going to give me 28 is less than 0.80 M. And then we're going to divide by 0.80. 28 divided by 80 cents is, what was that? 35? 35 is less than M. Now probably in your head 35 is less than M does not make a whole lot of sense, but we could switch that around and say M is greater than 35. If we drive more than 35 miles, then A is going to be less. Does that make sense? That doesn't make sense. M is greater than 35. Doesn't sound right to me. It probably is. So, you can leave it either in this order like it is, or if you want, you can switch it around so your variable is first. Shouldn't make any difference when they're done. Where'd that go? 21 then. For his phone service, Brian pays a monthly fee of $21. He pays an additional 4 cents per minute of use. The least he has been charged in a month is $63.16. Use M for the number of minutes to solve your inequality. So Brian pays a monthly fee of $21. He pays an additional 4 cents per minute, 0.04 M. The least he's been charged is $63.16. So here's back to those ones where we had all those inequalities where you just had to write what inequality sign went in there. The least he's been charged. So if $63.16 is the least he's been charged, what inequality sign should I put in between those two things? What was that? You're just guessing. So if $63.16 is the least, that means that's the lowest he's been charged. Then my inequality sign should be not less than or equal to, but greater than or equal to. This is the least, that's the lowest amount. So it could be the $63.16, but it could be more than that. So we want to solve that for M. The first thing we would do is minus the 21. So 0.04 M is greater than or equal to 42.16 if I subtract that. And then we're going to divide by our 4 cents. M is going to be greater than or equal to, if we take 42.16 divided by 0.04, 1,000 what? 54? Everybody else get that? Won't tell me. So M is greater than or equal to 1,054. It's a lot of minutes on the phone. 22, really doing the same thing, setting up our problem with the inequality symbol. Just this time I'm going to have variables on both sides. So it says company A has no initial fee but charges 70 cents for every mile driven. Company B has an initial fee of $60 and additional 50 cents for every mile driven. For what mileage does A charge more than B? So company A was 70 cents for every mile driven, so 70 cents times M. Company B, $60 and an additional 50 cents for every mile driven. We want A to charge more than B, so what symbol should we have in there? Greater than, right? A is greater than B. So now this time we've got variables on both sides, and so we solve it appropriately. In this case, we're going to subtract our 50 cents. So 0.20 M is greater than 60, and then of course we end up dividing. 60 divided by 0.20 gives me, what was that? Still didn't hear what she said. 300. 300. There's a fan right above me. It's hard to hear. So M is greater than 300. Ma is a medical equipment saleswoman and must choose between 2 salary contracts. In contract A, she gets paid $650 per month plus 20% of her total sales. So plus 20% of S, because it tells me to use S for her sales. Contract B, she gets paid $1,418 per month plus 8% of her sales. So 1,418 plus 0.08 S. For what monthly sales amount will A give less than B? We want A to be less than B then. So if I'm going to solve this one for S, what should I do? Subtract my 8% S, whoops, 8% S, and subtract my 650 then to move that to the other side, right? So 20% minus 8% would be 12% of my sales is less than 1418 minus 650. I'll let you do that. 768. And then, of course, I'm going to divide by my 0.12. $6,400. So S is less than $6,400. So if her total sales of stuff she got out of the store was less than $6,400, then A is going to give her less money than B. And one more. Caitlin is choosing between 2 exercise routines. In routine 1, she burns 39 calories walking, Then she runs at a rate that burns 3.75 calories per minute. So she burned 39 calories right away when she walked. Then she burned some more calories, 3.75 per minute, and it says to use T for the number of minutes for the time. So 39 plus 3.75 T. Routine 2, she burns 20 calories walking. Then she runs at a rate that burns 8.5 calories per minute, so plus 8.5 T. For what amount of time running will routine 1 burn at most as many calories? That doesn't even sound right, but I'm sure it was supposed to say at most in there. At most as many calories as routine 2. So routine 1 wants to be at most as routine 2. So if we're going to have at most, what symbol did we have in there for at most? Less than or equal to. So you might want to pull out those ones that you did previously where you had all those little things that said at least, at most, all of those things, so that you can look and say, oh yeah, that's what the symbol is. And then of course we solve it for T. Now in this one, if we're going to solve it for T, what might we want to do first?
Minus the 20.
Minus the 20 to move that over here, and minus the 3.75 T. And that way your T stays positive and you don't have to worry about dividing by a negative. So 19 is less than or equal to, if you take 8.5 minus 3.75, you get? What was that? 4.75. So 4.75 T. And then of course we have to divide. So 19 divided by 4.75 is 4, huh? 4 is less than or equal to T, or if we wanted to switch it around, T would be greater than or equal to 4 then. You can put it in either way. Alrighty. So that is the end of homework 12. Like I said, we have one more homework packet to do, so we have 7 more topics.